Hi everyone. In this video, we're going to continue our discussion of the calculus of logarithmic functions. At this stage, we've learned about the derivative of the natural log function, but what about a more general log with base a? Well, based on what we learned about the natural log, a reasonable guess would be that this should involve 1 over x, and if that's all you put there, you'd be almost right, but you do need to divide also by the natural log of a. But why is this derivative formula true? Let's prove it. Our task here is to show what the derivative of log base a of x is equal to. And the key is to recognize that we have the ability to change the base of our logarithm, which we can use to our advantage because we already know how to take the derivative of the base e logarithm. The base change formula says that we're allowed to express this as a base e logarithm, provided we divide by the log of the original base. This is now something we know how to take the derivative of, and you might be tempted to use the quotient rule here, which would work just fine, but an easier way is to recognize this ln of a is just a constant, so we can just pull that constant in front of our derivative and avoid the quotient rule by doing that. All that remains now is the derivative of ln of x, which we know is 1 over x, and now multiplying these two fractions together gives us that formula 1 over x ln a, which completes the proof. As soon as we know how to take the derivative of log of x, we also know how to take the derivative of log of u, where u represents something more than just an x. According to the chain rule, that would just be 1 over u ln a multiplied by the derivative of u, whatever that is. Let's, for example, see if we can calculate the derivative of log base 2 of sine x. In this case, our formulas tell us the derivative is 1 over u ln 2, where in this case u is sine x, and then we would multiply by the derivative of sine x using the chain rule. We know the derivative of sine of x is cos x, and that's all there is to this example. Also, make sure to put this new information on your formula sheet if you haven't already. At this point, we know how to take the derivative of a logarithm with any base, but we still don't know how to take the integral of a logarithm. We don't have the tools for that just yet, so for the time being, don't worry about it. That's all I have for you for now, so I'll wrap things up here and see you next time.